All right, so welcome. What we're going to be doing today is we're going to be looking at doing integrals with U-substitution. But before we get into that, I just want to work through the opposite of integration, taking derivatives, and show you how we can find a pattern and speed up our working. So here are some examples. First one here is cos of 3x, sine of negative 7x, e to the power of 2x, and so on, and so on. Now, if we have a look here, we see we have cos of 3x. That's not cos times 3x. Those brackets there are what you could call an argument. So cos takes the 3x and uses it to find a value. That's going to be important, but for now let's do it the long way, the boring way. I'm going to find the derivative of cos of 3x. So I take it over here, f of x, the function we want to derive, is cos of 3x, and then I say, well, this isn't just a straight x problem, there's something else. So let's take that and put it in the u bucket and say, well, 3x, wherever I see 3x, I'm going to write u. So now f will depend on u, and it will be cos of u. And it's pretty easy to find the derivative of that, but I find it with respect to u. So I find derivative of f with respect to u. Derivative of cos is always negative sign. This is just something you have to learn. Okay. And I can also find the derivative of u with respect to x, since u depends on x. And that's just derivative of 3x with respect to x, which is 3. Now, what I want to find is I want to find derivative of f with respect to x. What I have is the derivative of f with respect to u and the derivative of u with respect to x. And then you can see if I multiply those quantities together, the du's cancel out and I'll be left with df dx. So my working out is going to spill over to the side here. df dx equals df du, which is negative sine of u times du dx, which is 3. That's why I kept thinking 3. Okay, so when we multiply things together, numbers usually stay out the front of the trig functions. So this is negative 3 sine of u, but u is 3x. And there we have it. So we can write our answer there. And we're done. So, since we're done, let's do another one. Okay. So, second question is sine of negative 7x, and I look inside the bracket for what sine is taking, and it's not just taking x, it's taking negative 7 times x. So I can make some function u which depends on x, and that is equal to negative 7 times x. Then it's the same thing. Now my function depends not on x, but on u, and it's going to be sine of u. So taking the sine of this is really straightforward. Sorry, not taking sine, taking the derivative. I'm taking the derivative of f with respect to u, since it now depends on u. U as in the letter, not you, the person. Sine will just keep doing whatever, it doesn't really care what you are doing, or I for that matter, but its derivative is cos of u. So that doesn't, well, it kind of helps us, doesn't get us all the way. We also have to find the derivative of u with respect to x, since u depends on x. So we're just taking the derivative of negative 7x with respect to x. Derivative of that is negative 7, and we want to use these things to help us to find derivative of x with respect to f with respect to x, and the information we found, derivative of f with respect to u, and derivative of u with respect to x. And again, if I multiply them together, the du's cancel out, and we're left with df dx. So multiplying these two things is what I want to do. My working out is going to spill on here. So we have df dx, and that equals df du, which is cos of u, times du dx, which is negative 7, so we have negative 7 times cos of u, and u is negative 7x. So I can write that back in there, and our answer is there. So I said that we're looking for patterns and we're trying to make our lives easier. If I look here, I had cos of 3x, and the derivative was negative 3 sine of 3x. And I think to myself, well, the derivative of cos of something is negative sine of something. All I've really done is I've taken out the derivative of the piece inside the brackets, multiplied it out the front. Same thing here. Derivative of sine is cos, and then I multiplied that all by -7. That's interesting. So in the course of your maths education and career and life, you will do a lot of these questions and you'll kind of get to the point where you say, okay, well, I can remember it now. I remember it's called the chain rule, and if somebody holds a gun to my head and says, what's the chain rule, how does it work, then I can work it out the long, boring peasant way, or I can just remember I take the derivative of the brackets and multiply them out the front and derive the rest normally. So for the next situation, we are going to put some brackets in and use the shortcut. So I put some brackets in here because it's e to the power of what? To the power of 2x. And I say, well, derivative of e to the something is always just e to the something. So it's e to the something, which in this case is 2x. There it is, gotcha. And then we remember, multiply by the derivative of the something, which is 2 in this case. Done! Simples! Go eat some ice cream with all that spare time you have, now that you don't have to do all this boring working out. Okay, let's look here. We have some brackets, something to the power of 4. So I say, well, if I have something to a power, we use the power rule. We take the power, multiply it out the front, so it's 4 times the stuff, and then we decrease the power by 1, so that power goes from 4 down to 3, and the stuff inside the bracket stays the same. And then we multiply everything, because it wasn't x to a power, it was some bracket thing to a power. We multiply everything by the derivative of the bracket, which is 1. So no change there. Let's look at this case. We have a bracket to a power. So we pretend that the bracket is like x. We do the derivative. Power comes out the front. Power reduces by 1 to 1. You don't really have to write that, but it helps. And then the stuff inside the bracket stays the same. And then you multiply everything by the derivative of what's inside the bracket, which in this case the derivative of that is six x take 4. And depending on what the question asks, you may want to expand those brackets or just leave it as it is, that's fine. Okay, so I'm going to wipe this all off and we're going to have a look at integration with U-substitution.